Greetings and welcome to Descriptive Statistics Lesson 2.5, Measures of the Center of the Data. Here are your new terminologies for this lesson. Not very many of them, but still take your time to go through them. The law of large numbers is simply this. You're trying to figure out the mean, let's say, age of this large crowd. Well, you're not going to go to everybody and ask them their age and then take the average of that, find the mu of the population. So you're going to take a sample of those people. Now, if you only pick 4 and you take the average of these 4 people, then your X bar, your mean of the sample, is probably not very close to the mean of the population. Let's say you take a larger size for your sample and you take their average age. Remember, you're taking this sample out of your population. Okay, well, X bar, the mean for the sample, is probably getting closer to the mean of the population. Now let's take even a larger group for our sample and take the average X bar, the mean of their age, and it's getting closer and closer to the average of the actual population until our group is so large, our sample is so large, it is the population, then of course that mean would be our mu, our mean for the population. If the sample size equals the population size, they're the same thing, and therefore their averages would be the same. So the law of large numbers just means that you take samples of larger and larger size from any population, the mean of the sample will get closer and closer to the mean of the population. Let's calculate the mean for a list of data. We have actually done this before, so the equation is X bar equals the sum of X divided by N. So we need to know what the sum of our x's are. In other words, we need to add up all of the values of our x. 1, 1, 1, 2, 2, 3, 4, 4, 4, 4, 4. And this adds up to 30. We also need to know n. How many of these x's do we have? And we have a total of 11. So to calculate the mean of this listed data, we take 30 divided by 11, and we get 2.727272, and it continues and continues. So let's round that to 4 decimal places, 2.7273. Now let's calculate mean a second way. If our data is in a frequency table, we don't have to undo the frequency to be able to put it into a list of data and then take the average of that. We can utilize the frequency table itself. Here's the equation. X bar equals the sum of X times F all divided by N. So that looks like we need X times F to add to our table. All that means is we're going to take our X value, multiply it by our frequency F value. So 1 times 3 is 3. 2 times 2 is 4. 3 times 1 is 3. And 4 times 5 is 20. Now, our frequency we do need to add up because that's going to be our N value. 3 plus 2 plus 1 plus 5 is 11. And if we add up the X times F column, 3 plus 4 plus 3 plus 20 is 30. So our equation now is going to be X bar equals the sum of this X times F all over N. 30 divided by N is 2.727272. And again, rounding it to 4 decimal places, we get 2.7273. Now you might be wondering, oh, is the mean always going to be 2.7273? No, I actually took the previous data and just put it into a frequency table to show you that you can do that with the same type of data. Even though it was listed on the previous way of calculating mean, we could have put it into a frequency table and then calculate the mean. Let's try using a frequency table and our TI-84 app to calculate the mean of this data. We're going to have one list for our X values, one list for our frequencies, our F values. First, I want to clear out my app, so I'm going to say stat, clear my lists, and I definitely wanted my list 1 cleared, comma, and my list 2 cleared, because these are the 2 lists that I'm going to be using. Now, sometimes it doesn't really matter if you clear your list if you're just going to type on over them, but if you have extra values, let's say my previous list had 30 values and I'm only going to be using 12 of those values, well, it's a lot easier to clear your list first than it is to try and delete those extra values. I'm going to say enter, and now it's done. Now I'm going to enter my lists. For my stat, click on stat, go edit. And my list 1 is, like I said, is going to be my X values. 3, 7, 9, 10. Now it's very important that I get these in order because my second list is going to correspond with this list. And if I get these out of order, then I better get list 2 out of order, or at least in the same order as this one. Otherwise, my frequencies are going to be off. So 22, 23, and 24. Now for my list 2, I can just toggle over, and I'm in my list 2. And again, I want to say match these up perfectly. So for my 3, there was a frequency of a 7. Then I have 8, 14, 12, 14, trying to pay a little bit more attention to how I'm keying these in just so they're mapping the same. 14, 12, 10, and 11. Now, I can double check by looking at, okay, 2411, yep, that's right, 2310, and I can double check all of these. But now that my lists are in, I'm going to go back to stat, and I'm going to go to my calculate. Now it's one variable statistics, so I'm going to hit 1. My list 1 are my X values, but my frequency list is my L2. So second 2, L2. So my first list are my X values, my second list is my frequency list, and what the calculator is going to know that they have to multiply each of these co-pairs together first before it calculates the mean. So now I'm going to calculate. Now it's taking in consideration all these frequencies that go along with these X values to figure out its Q1, Q3, and the median value. That's it. To calculate the mean of group data is slightly different than our previous ways of calculating the mean for some data. So let's take a look at its equation. X bar equals the sum of Fm divided by the sum of F. Well, the sum of F just means the sum of the frequencies. The sum of Fm means the sum of the frequencies times the midpoint. Now, I'll explain what the midpoint is in just a moment, but let's now take a look at our table data. We have a column that has intervals, a column that has frequencies. Our intervals, for example, 50 to 56.5, 56.5 to 62.5, and it goes all the way down to 92.5 to 98.5. These are our 8 intervals. And then we have a corresponding frequency of 1, 0, 4, 4, and so on. What this means is that we have a set of data somewhere, the raw data, the actual numbers. For instance, the 1 means that I have one data that's somewhere in the interval of 50 to 56.5. Now, I don't know exactly what that data is. I'm not given that information. It could be 51. It could be 56. Could be 53.5. I don't know what the data point is, but I know I have one value that's in that interval. Likewise, I have no values that are in the interval of 56.5 to 62.5. But I have 4 values that are in the range, in the interval of 86.5 to 92.5. Now, part of our calculation is going to be to add up the sum of our frequency, sum of f. So we're going to add up the frequency column. 1 plus 0 plus 4 plus 4 plus 2 plus 3 plus 4 plus 1 is 19. So we know part of our equation. We know the sum of f is 19. Now let me talk about what m is. M is the midpoint of our interval. In other words, we need the mean of the two ends of our interval. For the first one, I'm going to take 50 plus 56.5 and then divide by 2, and I get the midpoint of 53.25. Now I'm going to have to do this for each interval. So 56.5 plus 62.5 divided by 2 is 59.5. Now, it's going to be very boring for me to talk you through each one, but they're all very similar. 62.5 plus 68.5, then divide that by 2, you get 65.5. Let me fill in the rest of the values. So now that we have the rest of the values for our midpoints, we're going to calculate f times m. In other words, the frequency times the midpoint for each of our intervals. So the first one will be 1 times 53.25. We get 53.25. Next one, 0 times 59.5 is 0. Next, 4 times 65.5 is 262. And we're going to continue to fill the rest of this column. Now that we have the rest of this column filled, we need to add this column up. That's going to be the sum of f times m. In other words, the sum of fm. We have the sum of fm, 1,460.25. Now we have all the parts and pieces to our equation that we need to figure out the mean for this group data. So the sum of fm, the 1460.25, divided by the sum of f, which is 19, and that gives us 76.855. That will be the mean for the group data. You've reached the end of this lesson.